Okay, it's time to start the first chapter of your algebra book. I want to explain what you're going to be doing here. Here's the first slide. You'll see in the top left-hand corner, Chapter 1, Section 1. You can find all the information, all the examples that we're going to do on pages 2 through 4 on your book. In your notebook, I'd like you to put down 1.1 and the title of the lesson, which is Evaluating Expressions. At any time during the video, hit the pause button, write down what's on the screen, and then hit play to resume the lesson. So do that now. Okay, so the next thing you're going to see is the objective. So after every single time that you start one of these, you'll see the objective. And again, this needs to be in your notebook, so please write down the objective for today's lesson, which is, can you evaluate algebraic expressions and exponents? Hit pause, then play when you're ready to resume the lesson. All right, we're going to start out with some vocabulary. And these are probably words you know. In fact, this lesson is probably something that you are good at already. But we need to make sure that we're good at this stuff before we get into the big algebra that we're going to be doing. So the first terms you're going to learn are variable and expression. And you probably know that a variable is just a letter or a symbol that represents a number. It takes the place of a number. An expression is kind of like a combination of numbers, variables, operations. Operations are like adding, subtracting, multiplying, dividing. Okay, so please get these words down into your notebook with a short little definition. Now, when we combine the two, we get an algebraic expression or a variable expression. And a variable expression is just an expression that has at least one variable in it. Now, don't write this down yet. I'm going to show you a couple of examples. And from the examples, you can kind of get the definition. So here's examples of an expression that's an algebraic expression and a couple that aren't. So if you look on the left-hand side, you'll see there's no variables. It's just 3 plus 5 times 2, or 12 divided by 6 minus 3. No variables. That's just arithmetic. On the right-hand side, we have algebraic expressions, like 5y minus 3, and 1/2 times x plus 4. So when the expression includes at least one variable, it's an algebraic expression, or a variable expression. When it doesn't, it's just an arithmetic or an expression that only deals with arithmetic. Now, what I'd like you to do is just take a look at this. Don't write it down into your notebook. It's not important. But the information is. Right? So here's a bunch of different expressions shown in different ways that we can show the operations. And the most important one is probably multiplication, because there's a lot of different ways of showing multiplication when we're doing algebra. So you'll see that we have 5 times a number in parentheses, or a letter, a variable, or just 5 times the letter n next to each other. That means multiplication. If we put a little dot in between two things, it means to multiply. That's not a decimal. That's just a multiplication dot in between the 5 and the n. For division, we use the division sign, but when we're in algebra, mostly you're going to be using a divided by sign, such as like a fraction bar or a slanted fraction bar like the one you see now. And then nothing really changes much with addition and subtraction. The key is probably the multiplication, because again, we don't want to use the letter x to show multiplication, because x is generally the most common of all the variables that are used. Now, your next term, and this is an important one to know, is evaluate. So we evaluate algebraic expressions. And what that means is when we put numbers in for the variables, and then we do the adding, subtracting, multiplying, dividing, and we can't go any further, that's called evaluating. You might hear some teachers or some kids call that solving, but it's not really solving. Evaluating means to put the numbers in for the variables and then do the math. That's it. So here are some examples. Take a look at the 4 examples on the screen. And notice in the top corner it says that for each of these, n is going to have a value of 3. So every time you see an n, you're going to put in the number 3. Go ahead and do that mentally in your head. And there's no reason to write these down, because I'm pretty sure you can do these without any real help. Okay. Excuse me. If you put 3 in letter A, 13 times 3 is going to wind up being 39. For letter B, we have a division problem. 9 divided by 3 is 3. The next one, n minus 1, would be 2, because 3 minus 1 is 2. And the final one would be 11, because 3 plus 8 equals 11. This is evaluating. We're substituting the number in for the letters, for the variables. Here's a few more. Again, do these mentally in your head. There's no reason to write them down. Okay, the 6 next to the y means multiply. So we're multiplying 6 times 2, which is 12. Down below we have 8 divided by 2, which would be 4. And C and D are both pretty easy. 2 plus 4 is 6, and 11 minus 2 would be 9. That's evaluating. Now, part of our objective was to be able to evaluate expressions using exponents. So we're going to talk about exponents now. And you've probably seen this before. Here's 2 to the third power. The 2 is called the base, and the base is the number that's going to be multiplied. The exponent tells us how many times we're going to multiply it. So 2 to the third power just generally means 2 times 2 times 2. And you'll see that the word factors appears under the numbers 2. Anything that's being multiplied is called a factor. So 2 to the third power would be 2 times 2 times 2, which would be 8. So again, it says write the words. Don't worry about writing this down. It's not really that important. But you know that 7 to the first power, that's how we would say this, is just 7. And 5 to the second power, which is how we'd say the second one, is just 5 times 5. Notice that we can also use exponents for fractions. So 1/2 to the third power would be 1/2 times 1/2 times 1/2. And the final problem would be 2 to the fifth power, which would be 2 times 2 times 2 times 2 times 2. Remember, those are multiplications. And we call them power because these numbers are going to get big, or in the case of the fractions, really, really small. Really, really quick because we're multiplying over and over and over again. Here's a few more. But first, an important thing to know about exponents is this. When you have a number that's raised to the first power, you don't write the exponent 1. Here's an example. 12 to the first power. You don't have to write 12 to the first power when you write 12, because 12 to the first power just means 12. So when you see a number like 12, you know it's automatically to the first power. Here are the other examples I was telling you about. So again, no reason to solve these. 9 to the fifth power just means 9 times 9 times 9 times 9 times 9. 2 to the eighth power, 2 times 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 2. I think that's about 128 if you did the multiplication. And again, notice that we can even raise a variable to a power. So n to the fourth power would simply mean n times n times n times n. And here's a couple of examples of that. These I do want you to write down. So please, in your notebook, write down example 4 and copy down the 2 examples. I'm kind of highlighting them with my cursor right now. We'll solve them together. Please make sure you write down step by step how these are solved. So x to the fourth power simply means 2 to the fourth power in this case, because x equals 2. 2 to the fourth power is 2 times 2 times 2 times 2. And if we do the multiplication, it comes out to 16. So 2 to the fourth power is 16. Now we have a decimal. You notice that we put the decimal in parentheses when we multiply by a power. So 1.5 to the third power is 1.5, or 1.5 times 1.5 times 1.5. I did the multiplication for you. You could use a calculator for this. But it's just 3.375. So 1.5 to the third power is 3.375. So we're kind of combining the first 2 things we've learned, using exponents and evaluating variables. Okay, here's your guided practice questions. Please copy them down, write them into your notebook. Evaluate, that means do the multiplication, and when you're done, I'll tell you the answers, and you can move on and resume to see the rest of the lesson. Okay, x to the third power, 8 times 8 times 8, that would be 512. K squared, or 2.5 times 2.5, is 6.25. And when d is 1/3, d to the fourth would be 1 times 1/3 times 1/3 times 1/3 times 1/3. Multiply the numerators by each other and the denominators, you get 1 over 81, 1/81st. Okay, now it's time to end the lesson. Final thing we're going to do is we're going to combine everything we did with some real-life math, which is finding area and volume of shapes. So here's our 2 shapes. We have a square and we have a cube. 2-dimensional square side by side. When we find the measure for a square, we look for the area, which is s times s, or side squared. When we're measuring a cube, we're going to find the volume. That means how many cubes can fit inside the big cube, and that's going to be volume equals s to the third power, or s times s times s. And we know that each of the sides of a cube or a square are the same. So when you see something raised to the second power, it's squared. To the third power, it's cubed. Excuse me. So here's our problems. We have a cube that has an edge length, that means the length of each of these sides, of 14 inches. We want to find the volume of the cube. Now, since it's made up of squares, we know that all of the edges are the same. So every one of these blue lines is going to have a value of 14 inches. And we also know that the formula is volume equals side times side times side, which is 14 to the third power, or 14 times 14 times 14. This is calculator math, but I've done it for you. The correct answer would be 2,744. Notice cubic inches, inches to the third power. Please make sure you put down the labels or the units anytime we're using measures. Here's the final question, and we'll be done with this lesson. This time we have a square, and we want to know the area. That means we want to know how many square units cover this particular square. We also know that the formula is going to be area is equal to side times side. And since each side is 14, we're going to do 14 to the second power. And when we multiply that out, we find out that the area of this particular square is going to be 196 square inches. So when we're measuring area, we measure in square units, like square inches, square centimeters, or so on. Okay, that does it. So we got a long ways to go with this book, but you finished the first lesson. Your homework is practice sheet 1.1. Please make sure you show your work on a separate sheet of paper and staple it on. When you're done, you can check the answers with the answers on the wall, because I keep the answers there. And then you can move on to section 1.2. If you have questions, come and see me. And hopefully you're enjoying this kind of learning. Thanks for your hard work, and let's get going.